For security.
All right, everyone ready?
I guess so.
Started. Thank you very much for coming. Welcome to Orchestructure. Thank you for the light action. It's an AMC 30 movie theater. So I am Mario Loria. I'm the co-organizer of Orchestructure. We've been around for just over a year now, and I want to thank Ithaca for this amazing space, which we'll be in the future for sure. Today we have Brian N with us talking about HashiCorp's Vault. He's been working with it for a week or two, couple years. So
couple days.
Definitely feel free to ask questions during his presentation, and then we have until 8 o'clock, hard cutoff. So you can mingle, you can ask him architectural questions, and he'll draw you fancy diagrams on the whiteboard. This is a meetup where everyone is open, or we want everyone to be open, interactive, talk amongst yourselves, and learn something. So definitely give me feedback as well. I want to thank Llamasoft. Josh is here. Llamasoft is a recent sponsor of Orchestructure, another awesome company, as well as Ithaca, who's giving us hosting space and the resources to do awesome things like this. And then we are doing a Orchestructure workshop, which I'll talk a little bit more about later. But that is going to be a 2-track Saturday 4-hour session here, actually, in this room and the conference room over there, where we talk about beginner and advanced topics and things like containers, Kubernetes, AWS, CI/CD, and all the fun tools that come along with that. So more details on that coming. Without further ado, I'm going to give it to Jay Street to talk a little bit about Ithaca really quick, and then Brian.
Hello, everyone. Thanks for coming today. So Ithaca, we are a mission-driven digital product organization. We have 4 products under that: JSTOR, ArtStore, SNR, and Portico. JSTOR and ArtStore mainly in this building, and we have cloud-based platform with 100% test automation and over 200 microservices. We do have some openings for front-end, back-end engineers, user researcher, and senior product designer. We have Eric Shannon here. He's our director of engineering. So if you want to know more, come talk to me or him after. Thank you.
So I'm Brian N. I'm assuming you didn't say my last name because it's not that bad. Nuszkowski. Let's all sit. No, I'm just joking. I'm trying to determine if I'm going to stand at this weird corner or sit down. So I'm going to introduce myself as I stand up, and I'm going to sit back down because I'm lazy. So this talk is really just kind of a culmination of a few years worth of work in HashiCorp's Vault. So I thought I would kind of hopefully organize it for an easy to digest format into this 56-slide presentation, spending hopefully less than 45 seconds per slide. So we can get out of here at a reasonable hour. As you said, if there's any questions during the talk, feel free to raise my hand. And obviously, if they're like completely off course and we're going to derail the whole thing, we can like write it on the board and we can follow up later, or you can email me and we can do that. But hopefully we can like knock through questions and everyone can understand and learn as we go along. So the 4 high-level areas we're going to cover in the talk are kind of like philosophy of why Vault and why it's becoming so popular. Mostly some, I guess, these are like philosophical opinions. So maybe I should have said opinions. Secondary, I'll talk about the architecture of Vault, some components that make it up and set you up for understanding it to be successful if you want to implement it, and some things around implementation and scale, both from the technical and a non-technical perspective. So like as any journey starts, there's a selection process for me personally in trying to find a secret store or place to manage all kinds of like sensitive information. And it was like, Vault seemed like it was very popular, and it's a single place would be nice for all your stuff. But then you begin to analyze and you say, well, there's this single place where all my secrets are stored, and oh my goodness, if there's a breach, it's going to be bad news. That's a risk you always need to be willing to take, and you have to kind of calculate all the positives that come along with a tool like this and use that as an assessment. Say, I'm willing to have this centralized place. It's super extensible, and there's audit trails, and we can have all kinds of identity access management around it. But I'm willing to like take that risk, and if something bad does happen, at least we can detect it and we can maybe remediate easily. So like nothing's perfect. So some philosophical quote slams, like obviously people who don't want to choose Vault because they don't want to put all their eggs in one basket. And a bird in the hand is worth 2 in the bush. It's kind of like if you have if we have this thing that already works and is super valuable, why not use it instead of prolonging implementing a secret solution because you're waiting for the perfect solution, and it might not ever come along and you'll never have a secret store. So I guess you get to choose which is the best mix for both of you. And again, this is like everything I'm going to discuss in the back of your mind. You say this is not perfect. Well, like good security is not about implementing perfect security because then we would never get anything done. It's about implementing better and iterating slowly and over time and finding better ways to improve stuff. So again, this is not perfect, better at the end. Well, Brian, this security solution sucks because X, Y, Z. Just remember this quote. I mean, I'll probably say it like at least 45 times throughout the presentation, so you'll be sick of it afterwards. So the problem statement we're trying to address is Vault doesn't deliver us anything new. It's not like, oh, we invented this new cryptographic primitive that's going to protect data in another way. No, that's not the case. It's using all the standard, like the standard algorithms that are around. They're just implementing it in a way that's easy to consume and easy to deploy within your organization. So the problem is, at least this is what the problem I have. Maybe you have the same problem in your organization. You have a secret and it's stored somewhere and you need to move it from some place to another place and you need to move it securely. Is that the kind of problem everyone has? If you say no, I'll just walk out because this will be useless. So I think that's most of the big problem we're trying to address. We're trying to move something from somewhere, some secret that's in this 3-dimensional cube to a 1-dimensional cube. Okay, so like taking this to a real world operation. So let's call this Operation Move the Keys. We've all had this situation. You have a web server. You have this. You have like the private key. You have the certificate, and you need to move it somewhere. Well, how do you? There are a few things we need to ask. Well, how do you protect and store this certificate? You probably log into your DigiCert or whatever, and you download it. It sits on your desktop, and you go home, and it sits there for like 47 months, and that's cool. So how do you store it? How do you protect it so that doesn't happen? And how is this, when you transfer it from one medium, either your desktop or S3 or some other place to another, how do you protect that? Kind of once it gets to the final destination, that's kind of like out of scope here. But once we have these secrets transferred to the place we want to be, like if someone gets access to those secrets, there's no extra magic stuff. Like once they're there and they're protected, so to speak, this is more about like delivering them from a place that's protected to a place that's not. So how do you do this? This is mainly like an operator-centric type thing. So typically this is like, I have this certificate that's protected on my desktop, protected with the password. The password's stored in probably like LastPass or some like KeyPass thing. So already you can have like the certificate's encrypted on this drive somewhere, this disk storage. The key's stored somewhere else. It's kind of controlled who accesses it. Or maybe it's like, it's in your, like what's the dominant config management tool? Is it who uses Chef here? Who uses whatever, the Puppet, who uses Ansible. It's like each has their own like weird security store thing. So you're probably storing it in that, and it's protected by a key. And when you run your like Ansible or your Chef cookie thing, it asks you for like a key, and you probably get it out of LastPass or some other place or some like secret text file somewhere else. And like you decrypt it and you send it via SSH probably to this box. That's typically how things work. Or you have some like really easy, like they just copy from the clipboard or you just SSH in the box and down. There's a number of ways that are not super elegant to deliver these secrets, and we all kind of like do what works best, and we kind of go forward from there. So moving forward, there's this little step back a bit. It's you. This is very operator like centric. The operator, like this is all revolved so far around you having to like input something to decrypt a value to SSH in. It's all about you managing these secret delivery channels, and that's not super scalable. The point is there's like several moving parts which often require like some type of repeatability, and they don't scale real well. So you're the operator and you're getting it from your Chef thing or your S3 bucket over here, identifying to your AD or AWS IAM, and you decrypt it with KMS and you put it on the box and this whole elaborate thing. You may have a solution that works well for you, but that's cool. So why not take all those pieces and kind of like centralize them into this one location, which is kind of like what Vault is really aiming to do. They're taking the identity piece, controlling who can access it, how it's delivered, how people identify themselves, and move into this kind of one bubble cloud type thing. So now you can use this one central point of secret storage, identity access management. And here I say IAM. I don't mean IAM for like AWS exclusive. I mean like the general term. I know AWS kind of stole it. And like the IAM is their thing, but this is the general term of how do you authenticate, how do you authorize who gets access to what keys and whatnot. So we kind of move this to a central location. And when we do that, we can do things like super scalable now, where now I can use Vault for getting a secret because I'm an operator, or now a system can identify itself to vault to get the secret and cut you out of the solution. Not about getting rid of you or anything. Your work is still very important. But now the system can do it automatically and not have you in this like kind of fragile step. So systems can leverage this automated process. An operator can, or individuals will need to share secrets with each other, or some type of like process, whether it's like some application in the container or whatever. So really we're going to talk about two main things here. There's other 3 or 4 different things that Vault can function as, but really we're going to cover like how you're going to manage delivering secrets. That's like our problem statement number 1. And problem statement number 2 is like secure operations can be pretty complicated. There's been the time like you've all been there, you're in Slack or whatever your tool is, like I need to deliver you this secret. I'm going to Slack it to you real quick, then I'm going to delete it. It's going to be all good. And then like, oh, well, you should encrypt it and send it to me. I use GPG. Oh, I use this OpenSSL command I found on Stack Overflow. This is like, there's no good formal way to say like, here's how you can encrypt this data and send it to me, or I can encrypt it and send it to you. So Vault has this whole other piece of like cryptography as a service, basically. So you can leverage these things are abstracted from you. You don't have to worry about having this new version of OpenSSL or a non-buggy one or whatever. You can leverage this API and your using identity to perform these operations like, hey, sign this value for me, encrypt this value for me, decrypt it. So these are like the 2 main things that will make your life much easier as software engineers, computer operators, or project managers, whatever. So to briefly cover some Vault architecture, it's written in Golang, if you don't know that already. So it's a single binary for client server. So when you go to vaultproject.io and you download this binary, this is the same binary you're going to use to run either the server or run your client locally. There's a little asterisk I should have put there. There's like, if you're an enterprise customer, you have to get your binary from another location, a bit different. But it's the single thing you download, so you don't say, oh, I guess the point is to make it easier. You get the Vault, you got to get the Vault client, I get the Vault server. Maybe there's like a weird mismatch and there's some kind of confusion. You can use this single tool to perform all these operations. It's kind of nice. So you can, this Vault binary, like if you want to start a local development server, you can do it ridiculously easy. You can start the server up on your laptop. You can experiment without having to like deploy this big, complicated environment. When it comes down to it, it's really just an HTTP API interface. If you start to use Vault or already do, and you run these Vault commands like Vault write, Vault read, etc., that's just basically equivalent to an HTTP get or put. This is just all HTTP under the covers. And some languages you use to interact with it are like JavaScript object notation, pretty standard stuff. And they went and invented this new thing called HCL, the HashiCorp configuration language, which kind of looks like it. And it's used for like defining policies and some other configurations. So if you're most people probably already familiar with JavaScript object notation, cool. If you're not familiar with HCL, you can plug it into your favorite editor and it'll automate. If you use Terraform, things like that, other HashiCorp products, this will be ridiculously similar to you, and you won't have a big learning curve. Learning curve is not difficult. Lots of examples you can look from that way. So the kind of the components of Vault we'll talk about. Like I made this V at the bottom. That's Vault. I didn't want to use like the Vault logo. I wanted to make my own. So this is just like a Google slide vector of a V. Actually, it's a box that I cut a thing out and made a V out of. So that stands for Vault. That stands for Vault throughout the presentation. So like these are the kind of the layers we're going to worry about. So this is really thin configuration shim. You can obviously guess what configuration does. Like you configure the Vault binary to do the things you want to do. You start up. We'll briefly touch that. It's pretty easy stuff. Either put it in HCL in a config file, or you provide it via an environment variable. There's this storage layer, which is like obviously you have to store all this data somewhere, and we choose the medium we store it on. S3, RDS. If you want to use MySQL, Postgres, there's all these backends. We'll cover those. There's this barrier, which is kind of like the secret sauce. Not really even secret because you can read the code, but it's this formula they use for protecting data when it's stored in the backend storage barrier, like in the area, and when it comes out and how that works. We'll talk about authentication, some policies, the secret engine, audit, which is like 2 slides, super easy. Then we'll talk about plugins, which can also make your life easier after you've mastered the first 4 squares on top of the V. So kind of behind the scenes, you spin up your Vault binary, you define which type of storage you're going to use. Let's say in this case, we're going to store stuff in a flat file. Keep it ridiculously simple in this example. Well, when data is written in and out of into that flat file through Vault, it kind of passes through this thing called the barrier. And the barrier has 2 components of Vault in it. They have the encryption key and the master key. And you're thinking, okay, how do those work? So the master key is responsible for decrypting the encryption key, which the encryption key is used to encrypt and decrypt the data. So the common terminology in like security parlance, there's like KEK, which is the key encryption key, which is an interesting choice of words. Then there's the data encryption key, and there's the data. So encryption key is used to encrypt the key it's used to encrypt the data that gets stored in the storage backend. Like I put some password from my database, the encryption key encrypts the data, stores in the backend. So like if someone does get access to your backend storage, they don't see the data's not in plain text. If we had Vault and we stored everything in plain text in the database, there'd be like no point of having Vault, right? So this is kind of the piece that fits it all together to protect that data. And the master key is this key that decrypts the encryption key to allow operations to happen. And so when this barrier doesn't have a master key, it's what's called in the sealed state. And if you want to think in the three-dimensional space, think of the analogy you always use as a bank vault. When the vault's closed, like when the door is closed and they spin the comm and it's locked, the vault is sealed, right? You can't get in, you can't get out. So that's in this case, we have the inside the vault, we have the encryption key, which is encrypted, and we have the encrypted data, which is encrypted by the encryption key. So when Vault comes online, there's this process of unsealing the data. And what that is constructing the master key. So when Vault comes online, it reads in this master key, and it says, okay, the master key is stored in memory. It does all the things like when you put an object, it then decrypts the encryption key, decrypts the data, brings the data back to you. So you're thinking, okay, cool. I did all this work of building this super complex secret management environment, and everything's going to be great. Now I have this master key floating around. What am I going to do with the master key? So like the problem in security is like we keep pushing these problems to somewhere else. There's not really a good solution for it. So okay, great. I implemented Vault in my company. Everyone's using all the secrets stored in it, but I have the master key like on my desktop or whatever, right? So HashiCorp's thought around this was, you can go ahead and use the master key if you want. And Vault starts up, you provide the master key, and it unseals the barrier, and you can do all your operations. But they like, okay, so again, this is problem statement infinity. We've solved all this problem by building a secrets management tool. Now we have a secret. What do you build? Another Vault to manage the master key, and you build another Vault to manage that master key, and you just keep. You never get any work done. So what they did is there's this crazy math problem, and someone figured Shamir, one of the RSA guys, is called Shamir secret sharing. This is not what the keys look like. I basically just made like some hatches, and this is an example. So I think, look, if you're going to email me later and be like, Brian, that is not a cryptographic key. It's not what it looks like, blah, blah, blah. I'm going to say, you're right. It's just garbage. I'm using it as purely an illustrative measure here. So what they do is they use this crazy math formula. Anybody take calculus in here? Me too, but I forgot it all. So what you can do is like, here's how it works. You can take any number of these, a minimum number of these keys, and it can construct the master key. So what it does, takes the master key, splits it into these, what they call shares, and then you can specify which number of keys you need to unseal the vault. So it's like, okay, I can give you one, I can give you one, you one. So now we have, say, a minimum 3 to reconstruct it. And you can think of the secret as this red line over here. And all you need in math terms, you need like 3 points, and you can define what that line looks like. So think about it as the secret. You need 3 keys to define what the master key, or you can say, I need all 5. And this gets into other topics later on of like, well, what do you do with the unseal keys? Like you have one on your desktop. Now you have one. Now the work's a little bit harder. I have to like compromise 3 workstations instead of 1 to get the unseal key. So that's the terminology used for these are the unseal keys. You can choose to bypass Shamir's secret sharing and just have like the master key in a text file and unseal the barrier that way, but it's probably not recommended. So what I talked about a second ago is the Unseal Philosophy. So what do? You're going to go deploy Vault to your organization. You're going to require 4 keys to unseal Vault. You have 4 of your operators. Every time Vault goes down for whatever reason, it restarts. Up, the barrier's sealed. It's not online. 3 a.m. Everyone is going to wake up and log in and get into like a shared screen and provide their key. Probably not. You're probably going to like put in a text file and it's going to read the keys on the Vault box. That's not super elegant. You could do it. Or if you're super paranoid and you're committed, you'd be like, I'm going to wake up at 3 in the morning every time the server restarts, and I'm going to manually provide my key in because I'm super paranoid and we work for some like government agency. You can totally do that. Or like the philosophy I like to kind of work with is like a sidecar. I've written this 200-line Go binary that runs alongside Vault. And when it starts up, it fetches the keys from somewhere like some object store, uses something like KMS or Google AMS to decrypt those keys and unseals Vault that way. There's automated ways you can implement this without being an enterprise customer. That's what the asterisks are. You got a checkbook and you want to give HashiCorp some money because you like support and you want to help them out. That's cool. That's like your prerogative. But if you're like a 4-person team, probably not going to work. If you're a big mega corp, you're like, we're going to buy enterprise support. No big deal. You can do things like you can have an HSM that stores the keys and like keys never leave this device to unseal That's cool. So now you kind of solved that problem. And then like, who here has used an HSM before? Who's used a hardware security module? Would you say out of 1 to 10, are you like 1 being like you're not very confident, and 10 you're super confident, and you're a professional HSM operator? What's the number?
2.
Okay. What is that? 10? Oh, so then you're gonna be very valuable at this. At working out implementing the HSM piece. Most people are like, you know, like I forgot the HSM commands, like copied them in a notepad, and now I deleted it. Now I can't really. So like, if your Unseal keys go away, you can't unseal the vault barrier, and you're in a little bit of a hard spot. There's a little caveat. We can talk about it later. And auto unseal is using things like, if you don't want to use an HSM, you can use things like KMS if you're an AWS customer, or Google's. I believe Google calls it also KMS, right? Well, don't hold me to that, but they have something similar that manages keys. You can use that to unseal it if you're an enterprise customer. Cool things about having these encryption and unseal keys, you can rekey them and rotate them. So if someone here does have it on their laptop and the laptop gets stolen, you can rotate those keys and not worry about people compromising data in your vault. So we talked about kind of the storage, the barrier piece, a little bit about storage. Any questions so far of going here? Any glazed over? Like, we can stop and just go have a beer if you want instead. Probably be just as effective. So talked about the barrier and how that kind of works. The storage piece, we'll kind of cover that more now. So when you go to spin up your vault binary, you're like, okay, well, I'm going to store my data somewhere, whether it's going to be S3 or whatever solution you happen to choose. There's 2 components. There's storage and there's HA storage. We're going to dig into that more. So these currently, as of 11:30 p.m. Eastern Standard Time last night, these are the supported data storage backends. So like, you want to store in Cockroach DB. I don't know what that is. I'm not going to lie. That's your thing, and you have a bunch of people who are professional Cockroach DB admins. You probably want to use that as your supported data storage backend, or like XCD file system. These 2 Google things, Postgres or MySQL or S3, you can store it there. But not all storage backends support HA. Like, oh, we're going to go with Postgres. Well, guess what? Postgres doesn't support HA from a vault instance perspective. So what you can do is, if you go back to this slide, you see there's another little block that says I can choose an HA storage block. I can store my HA in something like, I don't know, DynamoDB, and I can store the meat and potatoes of my data in S3. So you can mix and match these backends. And there's a warning. So I should have put a double asterisk next to community supported. If you don't have enterprise support and you're not paying for support, and you're using a community supported backend, which I think most of them are, except, can you name the HashiCorp product on there? Yeah, so that's the officially supported backend. And so you're going to, like, you have a support plan, that's the one you're probably going to want to use. But if you have 4 people on staff who are like MySQL experts, you probably want to go with you already have a MySQL backup strategy. You already have people who are well-versed in the technology. You want to choose your backend according to like what you're best at. We're going to stand this new secret environment up, but you've never stood up a Zookeeper cluster before. Like, we're going to do this. You may be setting yourself up for some hard times. This is some like operator advice. I could be wrong. So that's the storage backend. Here's an example of like in HashiCorp language, HCL, what it would look like. Like, I define my MySQL, I have my endpoint, my username, my password, kind of weird. HA storage. So now I bring this vault cluster online. The HA state is stored in DynamoDB, which is like seriously 2 entries, and the rest of it's stored in MySQL. You see any problems with this? Yeah. What's up with that? Any ideas? Well, first of all, you have to say, is this a risk? If someone does get a dump of the database, it's protected by the unseal barrier. No one has a copy of the encryption key. No one should readily have a copy of the split up master key. So if anyone, this password can exist probably in your version control repository or wherever you store your stuff. Probably not a big thing. If you're super paranoid, you can do things like encrypt this with another thing like maybe KMS, and on startup you can decrypt the value and populate into there. So these are things like, depending on your scale of paranoia, like you're really worried about people getting access to the database and spending a ton of money cracking it, they're probably going to compromise you like some phishing email instead. It'll be easier. That's typically how it goes. And like personally, I've had some issues with some backends because they're community supported, and you have to rely on either you being an expert to patch vault yourself, or someone else from the community to reach out through an issue and fix it for you. So those are things to be prepared of. So not without problems. So cool. We got Vault online. We have Unseal Keys managed. We're going to choose the method where Zach wakes up at 5 a.m. to type it in. So we're good. We're online. Now we talk about, well, how do people authenticate to Vault, and how do we control what type of things they can have access to? It's kind of like the auth and policy piece. So it has all these auth backends you can plug into. Like, for example, there's built-in username and password backend where I can manually say, Sarah gets a username and here's her password, and I like email it to her, and she can use that to authenticate to Vault. It's cool, maybe not. Or there's things like Kubernetes auth, which is like probably a deeper topic we can get into later. Or you can use your GitHub integration, or things like AppRoll, or an interesting one like AWS IAM. Well, you can have an instance authenticate itself to Vault. You don't need to be involved. You create an IAM role, attach it to an instance. Now that instance can pass its credentials to Vault. Vault can verify who it is, and you don't have to be involved for secrets delivery. So like when you auto scale off 5,000 machines, it kind of does this for you behind the scenes. Or there's things like people Okta or OneLogin or whatever the popular SSOs are these days. Those integrates with Vault. Or if you're like traditional, you can have LDAP. So you wire up your auth backend. Like you set it up. You put all the parameters in. Like I type in my LDAP credentials. Cool. It goes to the LDAP backend. It says, oh, is this user's password is what it is? What groups are he or she? And it gives you back a token. So the most important thing, like the authentication piece, is just a layer on top of the Vault token. And the Vault token is essentially the thing that's used to verify who you are when you want to talk to Vault. So whenever I talked about in the past slide, like this is just an HTTP API, you're always passing this header called X Vault token, and it's going to have your token in it, and that's token is going to dictate what you can do inside Vault. So you use LDAP in your org. You wire up Vault to LDAP, and you link some groups you're involved in LDAP to some Vault policies, which we'll get into in a second. You authenticate, and Vault says, cool. I delegated my authentication to LDAP. It says you are who you are. Awesome. Here's a token. Now you have this token that's typically stored in your home directory in .vault token. Or you can store it in memory, or store it, like the new cool thing is like to store it in your keychain if you use Linux or Mac OS or whatever. So there's this, you have the secret now that you have to manage locally. Okay, you're like, great, more secrets. I have to figure out what I'm going to do with this thing. So the token is kind of the back on which all the other authentication pieces are built. And typically, the cool thing about these secrets are they have TTLs attached to all of them, which is time to live. And this says how long your token's good for. Typically, users in an organization, you have to find out what your developer workflow, what's acceptable. If you want people who utilize Vault to have to authenticate every 45 minutes and the token expires, you can do that, but they're probably going to be really pissed off at you. And like, I have to authenticate every 45 minutes, and they're going to find ways to circumvent Vault because like I have to auth every 45 minutes. It's kind of annoying. Or you can do like a more realistic time frame, like 24 hours. I'm cool with. I'm cool with someone have a token 24 hours they can use to access things within Vault. And you see there's like on every token you authenticate, there's things like policies that are attached. So based upon LDAP group or whatever, I get this default policy, which is always going to be attached to me. And there's some other random policies. You can store metadata about the user. And there's this thing called the accessor that's attached to every token. And it's the same thing. So a token is really just a GUID like you see up there. But this thing is like a GUID you can use to query information about a token. So if you're an operator and you want to look up how long someone's token's been around or what effective policies they have, they can give you the accessor. And it's not going to allow you to they give you the token, you can become them, right? So they just give you their secret. So they give you the accessor, or you can choose to log the accessor in the log. You can use that to investigate, like, so-and-so has this privileges, here's the problems they're encountering, things like that. So there's some special tokens. There's the root token. So when you first initialize Vault, you bring the Vault binary on for the first time, and the unseal process doesn't happen. You do this initialization where it basically creates that master key and creates that encryption key. It also creates a root token, which is a token that doesn't have a TTL, so it never expires, and it can do the name kind of gives away root. It can do whatever it wants. So it can delete, add. So you can also revoke it itself. So some strategies and organizations are you keep the root token, you store it in a safe place. Now you have this other secret floating around. Or you create a group in your identity provider that maps to a policy that gives root equivalent, so you can control who can do things like that. There's a thing called a periodic token, which can basically be renewed to infinity. And there's the concept of like orphan tokens. So by default, I authenticate with my LDAP. I get this Vault token, and I can do things like now create child tokens of my token. So if I want to test a smaller scope token, like I'm an administrator in Vault. So if I'm going to test out some functionality and I'm really nervous about using my token because I'm an administrator, I can create this token that's a child of mine by default, and it can have less policies and less privileges than a TTL of like 30 seconds, and it goes away. But so anything there's like a whole tree. So if I create 500 tokens and give them out to everybody in the org, you get a token, blah, blah, blah. But I revoke mine, all the children tokens are also revoked as well. There's been cases where people like, there's operators who use Vault, and they're like, oh, I just created tokens for 500 people in the org, and I gave them all out to them. But the TTL on their tokens like 20 hours. Every 20 hours, everyone's token breaks. They kind of couldn't figure out why. It's because they're all tied to that. You can choose to create a token that doesn't follow the tree hierarchy and is not revoked when the parent is revoked, but you need root-like privileges to do so. And so there's a few pieces with the TTL. There's like the system defined. So you can say, I want every developer to have a 20-hour token by default. They can renew it. They can renew it every 20 hours up to a year, maybe. So that's cool. So this can happen over and over again, or you can say I want it to be 30 days. So it's really all yeah.
Back to the hierarchy. Can anybody create a child? The developer can say, hey,
yep,
I got a problem. I want to create a child token, give it to someone else to test for.
Yep, and they can only create a token it can't be more permissive than the token they have.
Right.
So it's like, oh, I'm just a person who has a token for my app. I'm gonna make a root token. That's not how that would be silly. But so they can create one that can be the same or lesser privileges. So you can, or some other philosophies are, I want to share something with you. I create a one-time use token. I create it, give it to you. You can use that token to post data to some space I have. Now it's never usable again. So that the attack vector is I slacked you a token. It's a one-time use. So if someone intercepts it and they go to you and you using the token to work, you can infer that someone took the token, right? So, but likelihood of that is pretty low. If you have a low enough TTL and a low enough use number on there. Make sense? So you can do things like specify the TTL when you create the token. You have the mount TTL. So like if I have a secret namespace called /HR, and I have one /engineering, HR can have a different TTL. It's higher or lower than for engineering group or whatever, thing like that. So you can adjust the TTL all over the place. So you can go to town on that. Over here, you can see some other stuff about it, like when it was issued, it's just a calculation based upon the TTL, timestamp, stuff like that, and display names too. Display names are interesting because, like, if you do issue a subtoken to someone else, you can name whatever you want. Like, cool, you could call it root, essentially, if you wanted. It wouldn't have the effective permissions of root, so there's no validation of like display name. So using display name as a way to audit and track things, and you'd be really certain, probably not the best. You can either store that data in metadata, so it's immutable, or you can just actually inspect the policies and try to go back up the trail and see who created that token. So these are tokens. Everyone gets one after they authenticate using their shows and authentication method. We can go see if anything I missed from there. No, we're pretty good. So here's some this is kind of a side note I just added the other day. There's some implications of using authentication providers that you don't trust. Or here's an example, like Okta just had a problem where this is the problem with open source software, but it's also a good thing because you have the power to fix it. Someone didn't implement the proper MFA workflow for their SSO, so when people could authenticate to Vault, even though their MFA device was locked out. So you have to think about things like that kind of cover all your bases. Just because I set up Vault, it's tied into Okta, I'm good to go. Nothing bad's going to happen. You got to kind of always be cautious about things and inspect that workflow. So there was another case where LDAP allowed null binds, and because it was null binds, you could log in as anyone's the blank password. You can do things like to get around that, like implement 2FA, which on these some of these authentication backends, not all of them, I think like LDAP, GitHub, Okta, maybe username and password support Duo MFA. That's the only MFA provider they support. So go local company. There's some enterprise, you can do custom things like you can implement MFA on certain paths. So like if I have a super sensitive secret at /HR / payroll API token, you can protect that endpoint with extra MFA, so someone has to perform a second factor to authenticate to that. So there's something to think about, like if you're going to implement either you're going to write your own or you're going to use one that exists. Kind of make sure those whatever you're delegating auth to is kind of shored up, or at least do an assessment of it. You thought tonight, like, I'm gonna come here and I'm just gonna install Vault, be totally secure. It never ends. You always got to keep pay attention. So I kind of just color around this briefly, and we'll go into a bit. How are we doing on time so far? Okay. 40 minutes in, maybe? Okay. All right. So every time you get a token, like there's a policy engine in Vault that says, okay, what can you do with this token? So either you manually map that in the Vault backend that says, people who authenticate with LDAP automatically get this policy. But then you can do things like pair it to groups. So LDAP group X gets Vault policy X, and they have the effective permissions to do these things. So a policy is attached to a token at creation time. So if I add you to an LDAP group and you authenticate, and I add you to one 20 minutes later, but the token lasts for 24 hours, you're not going to get those permissions to re-authenticate and kind of run through that policy engine, and it attaches the new policies to your token. Like here are some examples of what a policy would look like. If you wanted to author one, you can use HCL or JSON. I just go the standard way and typically use the HCL language. So here's an example, like this policy lets you create anything in secret, anything past the namespace secret. So anybody here familiar with S3, Amazon? So it's like, it's a namespace, it's similar to that. There's the concept of folder structures and there's files. So it's like a key value way to store secrets. So in the path/secret, whoever gets this policy can create objects there. Cool. And you can even get specific and say, well, I want you to only be able to read secret foo, and I want you to be able to do this custom thing, like you can look up your own token. Which by default, you can do, but I just gave it here for, you can do other things like system level things that allow people to get creative. I want some people to be able to create an orphan token. I have to define a special policy that lets them access the system backend. So these are the things you can do. And the policy directors are really like create, read, update, delete, pretty standard stuff. And there's things like, well, you can create a really permissive one. Like I want to allow everything on /secret, but I want to deny /secret/Steve or whatever. You can add a deny directive to the capabilities. Or there's like the concept, you can say you get pseudo rights to this path, which is like you can do anything you want. Or you can get even crazier. Let's get real crazy and say, in this path secret/thing, you can only create the keys with the value. You can only create the key with the bar, or a key with the value bar, and the values zip and zap, or you can create whatever with whatever content you want. Like there are crazy use cases where you want people to only store certain type of values, and you can control that here. If you're an enterprise customer, you can use like Sentinel, which is this like basically policy language you can templatize and things like that. So you can, it's pretty advanced. So we won't cover that here, but it's an option. So if you want to go, this is a thing that always comes up. People try to oftentimes put this in between two paths. The glob, as you call it, only work on the very tail end of a policy. If like I want to do secret */foo, it's not going to process that path. So it's only at the very end. Sorry. Sucks. I just saved you from getting globbed. I'm going to work on this for like two days. And like, oh, it's not working. And you're like, oh, I remember that one time. Only the glob at the end. And it's in a big red bold square on the docs that tells you about this. So just kind of brought that to the forefront. So cool. We talked about how to auth, talked about how policies are attached to authentication. Any questions so far? You could confidently go do this. So we'll kind of get into if you reflect back on problem space number 1, which is secrets, this is like, this is the discussion about the secret backend, all the other type of backend engines. Recently, this used to be called secret backend. I just changed it to engines. So if I use the term secret backend instead of engines, pardon me, I haven't updated my mental parlance yet. But some ones like, so what these do are, these are ways to either store data, secrets or sensitive, or maybe not secrets, maybe things you just want to store. Or you can do things like, we'll touch on the ones in orange. The rest of them you can go look up later if you want. But like, for example, I don't have a slide about this, but I'll talk about AWS. So you can use the AWS secret engine to do things like generate credentials that are temporary for users. So you have Vault set up. You're using LDAP as your auth provider. People can authenticate with their LDAP, and now you can make all these crazy AWS policies things they can do. So this becomes like your AWS auth broker, essentially. Or before, like you had this like 15 accounts and all this complicated shit you do. Now you can say, well, Vault's going to be the broker for AWS. And like, if you're in this LDAP group, you get a scoped AWS token that only allows you to do X, Y, Z. So that's a cool thing. But at the center of it, Vault needs to have really permissive permissions to AWS because it needs to be able to create all these policies that can do anything you want. So now your users don't, like, you're putting more trust in Vault. Not perfect, but better. That's the first time I said it. I was hoping to say that way more than
that sounds like
I have.
Though, that you've got to keep the authentication maintained in spots.
No. So like I can authenticate to Vault using my LDAP. But like typically what happens right now, like I have an org, I have LDAP and whatever my SSO is, but I also have AWS and I use IAM. It's different. Like that's all, they're not connected together. So I join the org, I get an email account, I get an LDAP account, and someone has to create me an AWS account. And like 4 different ones. I have to assume all these roles, and I have to do all this complicated stuff. I can just use I can LDAP off to Vault. Vault says, oh, you're part of this policy in Vault. I'm going to create you these AWS credentials that allow you to do only X, Y, Z. So you have to define, like you basically write IAM policies. You tell Vault, hey, when this person authenticates in this group, you give them credentials that are attached to this IAM policy. Does that make sense?
Vault is communicating directly.
Yeah, so Vault needs to have then access keys. Now, whether you want to do that by statically providing them the Vault on the server, or you can use things like IAM that are attached to the instance that's Vault, if you're running AWS.
That's there. It's the middleman, basically.
Correct. So, like later on, we'll talk about some design considerations, like where you're going to place Vault, how that makes sense to you. We talked about AWS. Talk about the key value engine, which is like, again, it used to be called /secret. So these examples are secret. They just changed it to /KV. So this is like when you first bring Vault online. I don't think you even get it anymore, but this is kind of the default namespace they give you. You can create as many as you want, and as many places you want to store, but it's this place called secret where you can write data. So here's an example of using the Vault CLI. After I've authenticated and all that stuff, I can say, I'm going to write to secret, the key will be something, and I can write these values. So in /secret/something, I write username, whatever, password equals thing. Cool. And if I read that, do Vault read secret something, it returns the password and the username. So essentially what you can think this is, so I'm writing this is like the folder, this is the name of the file, and this is the metadata inside that I'm writing. So basically, this is like a JSON blob that says key username, value, whatever, key password, value thing. You can think of it like that. What sometimes people will do, they'll have a namespace called secret infrastructure. And in there's like 500 different keys, like password A through Z. And they'll be like, oh, I only want to change password A, and they just do Vault write secret something, password A, and they write it, but it blows away all the other secrets. That's been a thing, and that happens often. Maybe it'll happen to you, and you'll learn your lesson. So you have to think about your key design. So whether it's like secret something /username, and you say value equals whatever, and you have like this isolated namespace. So in the future, when somebody wants to update one value, they don't blow away everything. So because like it doesn't just look for the value. It doesn't parse through all the values and say, oh, you only want to update this field. It doesn't do that. It just basically says, here's the new value I want to overwrite this field with in your storage backend, and it does it. So I'd recommend not doing that. Not making /secret/infrastructure with 500 key values. And then when you want to change one, you have to know all other 499 of them to also change at the same time. Like to repost them, essentially. Now you have a JSON blob with 500 secrets in it, and it's just we're back to square one. Why even have Vault then? Yeah. You can iterate through it manually. That's been a thing people ask for. It's like, so if you can have something at /secret/something, but you can also have a namespace beneath that. There is some protections around that where you delete like /secret/something /Zach. You won't actually delete something as well. So if you want to list something, you do Vault list, and you append. So what people do typically is like, oh, I don't know if this is a top level structure with values underneath it, or it's a folder within another one. I'll do like Vault list and the path. And if it lists something, oh, I can keep listing. Or if you do Vault read and it brings the value back, you know it's the final destination in the key value string, which is kind of annoying. So typically what people do is they write like in your language of choice, Python, Go, whatever people are using these days, it iterates through the namespaces. You have to have a super permissive token to do that. So it's also something to think about. Not perfect, better. And again, the same thing that down here, This is really like the same example. I don't know why I did that, but just you see 2 examples now. Another cool one, we talked about key value. PKI is really cool. So like the old way of like distributing certificates in your organization is like developers spinning up a new web service. They create their key pair and their CSR on their desktop. They submit it to you probably or some other operator. Maybe you have all this automation and I'm totally making this stuff up, but this is what my experience is. Like they send it to some person who has the account to DigiCert or whatever your cert thing is, and they submit it. You wait for them to get the cert back. Like you wait and you wait and you wait and you wait. Finally, you get the certificate signed and you go about your merry business. You have to figure out what you're going to do with your cert now. So the new way is you can use this awesome Vault PKI backend, which is basically it takes the complicated pieces of you typing OpenSSL request, key size, whatever, generating the CSR and entering like wrong state information like you always do. And you just write to this endpoint, and behind the scenes, it manages all the keys inside Vault. It does the CSR for you. It signs it, and it returns the certificate back to you. This is if you have like your own internal PKI. So if you have your own certificate authority, you can have the roots in Vault. You can have a separate intermediate in Vault, and you can have people just write this command, and they can get us based upon if some engineers in the proper group to issue a standard certificate in your org. They just put the common name. And you can define all kinds of parameters around what names are allowed and whatnot. They get a cert back right away. They don't have to generate the private key themselves. They don't have to generate the CSR. You can control the key size and all the stuff. So it's good for users, even better for systems. Because now, like, say you don't use load balancers for whatever reason, or even you do, and you need to have your auto-scaling group comes online and expands to 500 machines. It can identify Vault by itself. It can issue the PKI request. It can receive the certificate all when it's coming online. You don't have to like worry about typing the key in when you're running your chef thing or whatever. So this is pretty cool stuff. This is gonna be like a whole day to talk about it. So we'll just kind of cover it there. We can have questions afterwards, but basically it's a super abstracted way to issue certificates in your organization. Some other cool ones that don't, for some reason, require their own slide, SSH. So you can do this thing. Anyone ever heard of signed SSH certificates? So you can have this like CA cert. So like as your org grows, like the old problem, I got to copy everyone's public key out to like 500 boxes. And when, Susie or Steve quits or joins, you have to go and like clean all that up. In this scenario, you have this one CA key you put on these boxes, and you got people use Vault to sign their public key, and you can access all these boxes. So it's a cool way. Or into this cool thing like one-time SSH password. So there's like a Vault little agent that runs on the server, and it talks to Vault, and you authenticate to Vault. You get a one-time password to SSH into the boxes. So, but you need this coordination between like the SSH one's much more offline and scalable. The one-time password is like, well, every server's got to be able to talk to Vault, and there's more moving parts like there. Or if you're not a big fan of using like a Duo Mobile or whatever other time-based one-time password apps, you can use Vault for that. So you can say Vault read, and you can get a 6-digit passcode that expires in 30 seconds. So essentially, it operates as the app. I don't know. And there may be a reason to use this. Like I have a few edge cases, but typically you're using some other MFA to authenticate to Vault, so you're gonna need your phone anyway. So if you want to have some out-of-band time-based one-time passcode, you can use it to generate that. So it's the same thing as like when you tap your Google Authenticator or whatever, your Duo Mobile, you see your 6-digit passcode that rolls. This is the same thing, but you get a command line version of it. So problem space number 2, which was cryptography as a service. That's what's called the transit engine, which is super cool. You can do things like upload payload to it. It'll decrypt it for you and return the encrypted blob. So like no one ever needs the keys never leave Vault. So people post data to Vault. Team A is only allowed to encrypt data. Team B can decrypt it. So Team A posts this payload to Vault. They get back the encrypted blob. They send the encrypted blob to Team B. And when they want to decrypt it, they post it to Vault. It decrypts it, gives them back the. You can choose all kinds of parameters like key type, key size on the back end. So you can do all this stuff you want. They have a random byte generator. Like, again, everyone's technique for this is different. If you want to standardize across the org, you're like, oh, the one they use in here is not the best. Well, either patch it or use it. Like, your random byte generation strategy may be different than your random byte generation strategy. So you can have a centralized way of kind of generating random bytes for whatever. You can do things like hashing as a service, HMAC as a service, or you can do cool things like signatures. So if you like distribute binaries to customers and they want to validate that you sign this payload, or even internally, you can use the signature component of the transit to say, oh yeah, this is signed by who it is. And typically how you do this is like, if you don't have Vault, you have like some guy with the private key or gal with the private key on their laptop, and they do the same thing. Like you send it to them in Slack and they run the signature and they copy and paste it in there. They send it all around. So this again is just centralizing all this effort into one spot. This is one I added at the last minute. We'll cover this later, actually. Sorry, that's a teaser. But so we talked about all the secret engines. Now here's the audit one. 2 slides, super simple. Like you should enable, it's not by default, but you should enable auditing in Vault if you can. There's 3 supported backends currently. I believe it's, so there's like file. So you basically log the audit log to a file. If you choose, you say the file path is standard out, it'll send it to standard out. For all you cool container folks in the building, you want to send all your audit logs to standard out. Syslog is an option too, so you can send it to a syslog collector or to like a Unix socket if you have some boutique custom solution. So this is like what an audit log kind of looks like. Every request to Vault, there'll be 2 entries in the audit. So as you can see, this type is a request. Someone requested it, and what they get back is a response. And what you can infer from this super easy to read text I put on the screen here is things like, oh, this is the client token they used. Obviously, we're not going to put the client token in the log because then what's the point of having Vault? So they do things by default, like they HMAC these entries. Now you can choose to individually non-hash secret. Like, so you can choose to not hash this if you want, and all the client tokens are in the log. And maybe that's cool for you. There may be a reason, and I'll talk about one reason why you may want to do it. So there's a thing like you can see, oh, root, someone's using a root token to do stuff. Probably not good. Here's what policy they have, root. You can see what they did. So they made here's the path they requested, which is secret data hello. And obviously the secret's abstracted. So they made a request and they got a response and there was no error. This is how, like, if there was a problem with that request, the error payload will be filled in with some probably semi-helpful data. Now you're saying, why on earth would I want to not hash something that's returned? Well, there have been cases where when you return the data, the secret data, there's something that's not secret in there. That's a unique identifier that you want to be able to read and track down the request. Maybe like if your application makes these request IDs, and I don't know, I'm just some scenario where maybe some of the secret data that's returned is not so secret, and it's an attribute you can use to trace down and do forensic on some request. You can choose on the mount/secret, say, hey, if you return a key called like not a secret, it won't hash it in the audit log. You can do things like, oh, here's the address, which in this case is not very helpful at all. But you can add things like x44 headers so you can see who makes the request if it's in front of a load balancer, et cetera. So things you can use the audit log for is like Audit Intelligence. Obviously, you're going to put Vault online. And you're going to like protect the root token. You're not going to put it on your desktop. And you can parse whatever your log solution aggregator of choice is. You can say, well, if you find any things in the log that says root tokens being used, alert on it. You can determine like, hey, people are doing malicious things. You can detect the log for root token usage. Or there's a super cool thing called the /raw endpoint. You have to enable this specifically in the configuration, but you can basically bypass all the crazy per secret engine checks. You have to be a root user, but you can make a request to raw, just dump the data back from the barrier. It's probably a pretty important one. If people are doing raw queries or they're actually using the raw endpoint, probably something bad's going on. Or you're using it for a valid reason, you can move on. And you can do things like usage analytics, see how many requests are happening, how many active users. This is what I do personally. I basically parse the JSON and like do some type of calculations on it to say, what are my top requests, what type of errors, who are the active users in the org. You can do some intelligence on it based on that. So here we talk about the implementation and scale component, which is mostly non-technical and mostly about administrative scale. So typically you'll start out with your Vault design, like, oh, this one Vault binary running. It's going to be attached to a database, cool. And as you mature and to become super popular, you like, I don't want to use a load balancer. So let's say you do 2 Vault instances. Well, only one's going to be technically have access to the data. And so you have 2 Vault instances and no load balancer. There's this thing called request forwarding. So if there's vaulta.company.com and Vault B, and it's in front of like a round robin DNS, you get sent to Vault B, it'll redirect your client to Vault A. So whatever box is active in the cluster and has the unseal barrier lock, it's the only one that can write to the data store. So you can't have like 50 things writing to the data store at once through the barrier.
Would B send all requests or just write requests?
That's a great question. I'm going to say it's all because I don't think it discerns the path type. I very well could be wrong. We can follow it up after the fact.
So
I just take it for granted.
So it's not for performance reasons. You can do it.
No, it's because like an exclusive lock on. So then like, this is not a super good solution. If I have a load balancer, am I going to go, if I have like 50 vault nodes, I'm going to go in on vault node Z and get redirected to B, but B is a standby. Now I'm going to go to C, and C is. So what they did, they cooked up this thing where in the back end, so by default, vault listens on port 8200. And if you have a cluster with HA enabled, then listens on 8201. And what the vault nodes can do then, they can become aware of each other by, they all talk to the data store. They all write some data to the data store. Now they all establish these like back-end TLS connections to each other. So they all come online. One's elected. So in this case, B is elected the leader. So it's has the exclusive lock on the data store. But in the back end, they all have TLS channels between them now. So if a request comes in on C, it's forwarded on this back channel to B. B services the request, sent back through that transport to C and back out to you. So while B is still doing a brunt of the work, A and C are still forwarding requests on the back end without having the client do redirects. So it's basically like they prevent these self-signed certificates, and so it's TLS to each other on the back end. So there is some coordination using that data store to do that.
Ryan, what does it look like if he dies? What is the kind of time of like that?
In my experience, based upon like how mature and well developed your HA backend is, relatively instantaneous. Like I do redeployments and upgrades in real time with like 10,000 requests per second, and no one ever complains about it. So, but those if you have a majority read, it's all about your workload. You maybe have a special case where you're all reads, no writes, but I'm all reads, 2% writes. So it may be different, like performance wise.
So is this technically the HA setup because there's no locking on the back end? Or is that what we?
Well, so I guess the dotted line means it doesn't have an exclusive lock.
Oh, okay. So
Yeah, so that's my. This is my.
They're all going through these still.
No, it's just like illustrating that if the request would go through C, it's not the best drawing. Sorry. And so the request would be serviced by C, but B is going to read and write the data through the Unseal barrier from the data store and present it back to the requester through that. And you can scale this out like as much as you want. Pardon? I get.
A or C if he was the leader.
I don't know. So I could lie and be like, "Oh yeah, it's fine. It's all good. You're gonna be great. There'll be no problems." It's like some rap thing, maybe. I don't know. Yeah, I haven't got that far, but so you can either, to get around not caring about this, you can set an SLA of like 99 something. So like these requests that fail are expected. So you lower the expectations. It's like a hack for your job. So like
Under pros, over
Yeah.
deliver.
Better not perfect.
Yeah, there you go.
Did you say you've seen tens of thousands?
Sometimes, yeah, depending on.
I understand it's like a service with startup.
Yeah. Well, there's like for example, let's say you have like a CI environment that like people like there's 5,000 developers and they all have a branch and they're all running tests, right? And it all needs a secret, things like that. So that's the use case where it could be like a high read environment, or someone has like a job they just ran and it goes crazy and just reading. And see, like some people when they implement Vault in the application, they don't respect the TTL. Like, oh, is the token already valid? I don't need to make a new request. So they'll go through the auth chain every time, even though the token's valid for it. So like you can do things like you can go through the audit log and infer things like that and talk to your users and help them tune those requests to be a little more efficient. But if like you got a ton of money and like you just want to scale out like crazy, go for it. You don't have to worry about it. No, there's an open issue that's always open about implementing rate limiting, and that's kind of like a topic of, do we want to do it or not, or do you want to put that upstream to handle that? Or yeah. So to kind of cover on this point, it's not really well displayed, but this thinks about your deployment implications. So are you going to deploy Vault on this giant Kubernetes cluster? And now there's like, you may think you understand all the isolation, or you're not, because again, the Unseal key is stored in memory, the master key, like you're running on all these shared hosts. So when you go to design Vault, how paranoid are you? Are you going to have like a separate AWS account? You have a separate compute cluster? You're going to use bare metal hosts because you don't want to risk it? Those are design considerations you need to make. If you're cool with like, yeah, Vault's kind of important. I run like some company that doesn't really matter. Like the it's not a huge risk. Like you need to really accept that risk. You're not going to invest the time. You may want to, like I think someone, CoreOS just released a way to like run Vault on Kubernetes, like a good, like a standard way of doing it scalable. So you either want to build your own Vault cluster and make it independent and kind of manage it as its own isolated resource. So if Kubernetes goes down, there's a problem with that. You have to think about, you know, who bootstraps who. Like if Kubernetes can use Vault to get it all secrets when it comes online, and Kubernetes isn't online. Those are like some design considerations, I guess, you need to think about. Are you going to isolate it? Are you going to, you can run in a container, but just run on a dedicated host. All decisions you need to make when you design it. Or you're going to say like, we're just going to run one host or 50 or things like that. Or kind of load balance. Load balancing, it's like an interesting topic because you'll think you'll profile your usage you're going to use and someone will like abuse it and you can never forecast. So it's all about being able to intelligently process those audit logs. There's also like, there's a piece which I forgot to cover. It's called telemetry. Basically you send a signal to the process and it emits like some latency metrics about the process. And you can use that to like send it to your favorite stats collection tool and see how it's performing. So you can make those decisions, not like a set it and forget it type of thing. This is like I'm going to install Vault and I'm going to go on vacation for 6 months. It's probably not going to happen because it's technical problems not going to be the problem. Like you're going to build 20 nodes right away because you want to be robust and all this stuff, and you're going to have all these T's crossed and these I's. So technical scaling is pretty straightforward. Like we scale out, we scale up, we're good to go. So scaling and adoption, like so having people adopt Vault, then building policy around the people who are adopting it is the big problem that I face right now. Like new teams are adopting Vault in their workflow, but we have to build new policies constantly, and we have to review those policies, and people want to self-service their policy. If they can self-service the policy, they'll be dangerous. So there's this weird game of how far do we gate the process of like policy creation. So oftentimes people are like, I want to use Vault, or people off the Vault by default, and they can't do anything because the default policy is like it's least privilege first. I off the Vault, I can't do anything. Well, what do you want to do with Vault? Store stuff. So what I've kind of coined this 4-question assessment I send to people in the new person, I want to use Vault. Well, what data do you want to store there? You're going to store a plain text secret, or someone will say, oh, I want to store an SSH key. Oh, well, we have this SSH signing backend. You want to use that instead? And the conversation shifts. So usually with number 1, you can identify what they're trying to do and direct them in the right solution. We want to store a Postgres connection string that we're going to read. Cool. You're probably just going to store plain text data. So that's like the A point. 2, who's going to manage the data? Oftentimes it's like this whole team needs access to Vault. So you give them access and they all have admin. Like, well, then one guy deletes this. Like, well, I need admin, but they need to read write. So who's going to manage it? This team. Who's going to use the data? So you two operators are the admins. So who's going to use it now? A user? Is it meant for end users? Or is it meant for things like robots or EC2 instances or Kubernetes applications or things like that? So how is it going to authenticate? That determines like, are you going to use the LDAP auth backend? Or you can use IAM, or you can use Kubernetes auth backend. And using number 3, you can implement so number 3 basically tells you, do you use Kubernetes, do you use auth? Or, hey, we have a new one. Like we have a factory full of robots that move packages around. There's no auth plugin for Vault that allows a robot to auth. We have some new way we want to authenticate, so you author a plugin. Now, number 3 is answered. Now you have to do some custom work to fulfill number 4. Those may be things you need to do. So it's always like an evolving, the 4-point Vault adoption plan. So I just coined it. But I think we don't have too much time. Are we doing okay? It's 7:14. Some advanced topics are like plugins, just what I kind of talked about. If you have an authentication mechanism that you you want in there and they don't currently have, well, you can, the plugin documentations, it's evolving and getting better. You can read that and figure it out and kind of build your own authentication plugin or your own storage plugin. Like there's no PGP secret engine. So someone wrote one and you can install it into Vault. Now you have that capability. So everything's kind of plug and play. But you have to trust, trust, audit, verify, defense in depth. So I recommend you read the API docs. Like those usually answer a lot of the questions. Sometimes you have to read them 300, 400, 400, 300 times, but eventually you keep reading it. And most of the data is there. And if you are lucky enough to work with Go often, like spend some time in the code, even if you don't, always want to get into Go and you're committed to deploying Vault in your organization, spend some time poking through the code. You can download it and you can add a million print statements everywhere to figure out what's going on if that's your debugging method of choice. But that's kind of the way you get good at it, operating it and using it from inside out. So that's it.
That was.
And if it doesn't work out, sorry.
So
don't blame me.
Yeah, it could go awry and you could lose everything. Don't blame him. But his contact details and he'll be around and the slides will be coming out, so you'll be able to find him. So a couple quick things from me. I know you guys have been sitting for a while. So we're looking for anyone who wants to give any talk about something that they're passionate about, DevOps infrastructure related. This is becoming the premier group somehow. I don't know what I did, but you guys are awesome. Thank you for making architecture what it is. And this is probably one of our biggest meetings. Please bring awesome advanced topics like this where people can come and really get a sense of how to work with this. I actually have a question for you. What is the biggest barrier to entry for most teams, most tech teams, DevOps teams, for rolling this in their company? What is the biggest thing that's stopping them from doing it? Is it secrets is the least priority? There's so many other more higher priorities. Is it handling the splitting out of the keys? Like how do they the structuring? What is?
To be honest, it's like building a library around migrating all these apps that currently use secrets and environment variables into this new way.
Yeah. Right. Okay.
Because it doesn't have a huge, if the org's not committed to security, like the value add's not there.
Exactly.
No performance increases. There's no, their life's not going to be easier. Maybe their life's going to be more complicated because now they have to implement this authentication flow in their application.
Yep.
And Vault becomes another dependency. So it's getting the organization comfortable with that. So
Requires them to clean up tech debt.
yeah, yourself too, because like Vault needs to be rock solid.
Mm-hmm.
Now, like if you work for a robotics factory and all the robots can't talk to Vault, and then they can't move boxes around, and like everyone's looking at the security team.
Yeah,
So
exactly. Awesome. So the next presentation will be on May 30th. Josh Lynn at Lamasoft, a really cool space, and he's going to be talking about basically DevOps moving to Kubernetes, right, from Hacker and Terraform and other kind of AWS-centric tools. So that should be a really good talk as well. So the workshop I mentioned before, on Saturday, May 19th, that will take place from 11 to 3 p.m. There will, of course, be food. There will be 2 tracks. I'll draw on the whiteboard how the tracks are going to work in the topics, a beginner and advanced track. We had a survey that went out, I think, a month and a half ago that Bob put out. And we got like 40+ responses, which was wonderful. Thank you very much. We tried to appeal to meetups in Detroit, in Lansing, in Toledo, in kind of this area of there's other events like Orchestructure that are happening. Adjacent, topics and whatnot. And we got a lot of overwhelming response around containerization, Kubernetes, obviously, but also AWS, CI/CD concepts, and a lot of the other tools that you guys are using, Terraform, Packer, Vault, things like that. So that is what the focus for the workshop is going to be. I will be creating an event for that one of these days when I have time. And so look for that this coming week, hopefully. And so other than that, I don't have too much else. When you're leaving, the bathrooms are where you came in near the elevators. There's some signage. I'm going to open it up to the floor. If anyone has an announcement about anything that they're working on or looking for people or looking for a position or want to see something presented here, please bring it up. And someone else who's awesome at it may be able to come and talk about it. So I'll let you guys kind of do your own announcements here and then talk amongst yourselves and have a great one. Thank you.
If there are security engineers, the company I work for, we build autonomous cars. So if you're a security engineer and you want to help build autonomous vehicles, hit me up. Probably have to move to the West Coast, but
Who do you work for?
Cruise Automation. It's a General Motors subsidiary.
That was large scale. You started talking about 10,000 requests per second. So I was thinking,
It's a GIF company. Like GIFs.
yeah, yeah.
That's my announcement. So if you're a security engineer and you want to work on some crazy stuff, and my contact information, you can email me out of band and not announce like, yeah, I'm looking for a job, and your boss is in the room. You can do it on the down low. It's okay.
You were involved on a physical server or like with any?
Virtualized.
Oh, virtualized in there. The virtual pattern.
You got bigger problems than. Yeah.
So, if I wanted to play both like compliance teams like that, has it ever been audited? Is it any actual company pay?
Yeah, they do. HashiCorp pays third parties to audit it, and they have all like the certificate of authenticity. Like there'll be a period like if your company like follows the legal chain of command, like the lawyers will have to review the contract, all that stuff, and for a multinational global company. It's not out of reach. If you have any questions you think about later, feel free to. You can tweet me, but I tweet like once every 5 years, so it's not going to help you out at all. So they can email me. Yeah, there's a Slack group too. You can.
They do need to network. Yeah, if you're not already in it, they need to network around kind of all the startups and companies that you guys work for. That like it's the Slack is wonderful. Everyone is almost so it's pretty small. So we have a channel in there, hashtag has over 70 people now. I don't know, but it's actually pretty active now. So any sort of DevOps infrastructure dev topic, Brian hangs out in there once in a while. Yep. So actually, Brian Green from HashiCorp, I don't know if you know him, he's doing a talk in June about something. Maybe he'll overshadow you and do a better bullet talk or something.
Prove me wrong, I guess.
I don't know. Probably more around Unseal and Terraform. I think those are kind of leading edge. So
yeah, I had some HashiCorp stickers, but I forgot them. There was only like 3 Vault ones, and the rest of our products, so it would have been very disappointing. Maybe I'll try to get more and send them to the workshops.
Yeah, so May 19th, and I'll get that event out soon. More round of applause for Brian.
Yeah.